So let's talk a little bit about special right triangles. We already know how to find sides of triangles when there's a right angle. When we've got a squared plus b squared equals c squared, and they gave us two of the sides, and we're trying to find the third one. With certain types of triangles, you don't actually have to have two of the three sides to find the third one. For a triangle that has certain angles, like this one here, it's got 45, 45, and then a 90-degree angle. It's got a special name. It's a 45, 45, 90 triangle, and it has special traits. For one, something we learned recently is that it's also an isosceles triangle. This line, this side is the same as this side. They're congruent, since their opposite angles are congruent. Other cool things about triangles like these is that there's this fancy ratio of, since these two are the same, 1 to 1, the opposite side, the hypotenuse, is square root of 2. So this is something you can memorize, write down. That way, every time you come to a triangle with 45 degrees, you can use it to figure out what the sides are of a different one. So I pulled from IXL this example right here. It's a 45, 45, 90 triangle. On the right here is our example with the ratios on it. 1, 1, square root of 2. This problem wants us to find P. They only gave us one other side. So we can write out our ratio as P over 1 is equal to 8 square root of 2 over the square root of 2. This side is to this side as the hypotenuse is to this hypotenuse. We're solving for P. So we can cross multiply and we get P times square root of 2 equals 1 times 8 square root of 2. Now the 1 can just go away and we get P square root of 2 equals 8 square root of 2, since 1 times anything is itself. I'm going to divide both sides by square root 2, and I get P equals 8. Simple as that. The sides to this triangle are 8, 8, and 8 square root of 2. Another type of triangle that is special is called a 30, 60, 90 triangle. We've got 90 degrees, 60 degrees, and 30 degrees. Similar to the 45, 45, 90 triangle, there is a ratio that will help us with many of our problems. It goes like this. The hypotenuse is 2, the short leg across from 30 is 1, and the longer leg across from 60 degrees is square root of 3. Hypotenuse, short leg, long leg. So let's use this to help us solve a problem in IXL. Here's our problem here. There's the ratios. Let's identify each leg of the triangle. Our hypotenuse is across from the 90 degree. The short leg is across from the shortest angle, so this is the short leg. And the long leg is across from the 60 degree angle. I'm going to go ahead and label them on our example over here again. This is the hypotenuse. Across from 30 is short leg. Across from 60 is long leg. Similar to our other 45, 45, 90 degree triangle, you just have to make sure you line up the correct ratios. So long leg to long leg, short leg to short leg, hypotenuse to hypotenuse. Since we're solving for this hypotenuse, we're going to go z over hypotenuse over 2 equals whatever our other given information is. Since we've got 10 short leg over here, the ratio 1. Again, we're going to cross multiply and get 1 times z equals 10 times 2. 1 times z is z, and 10 times 2 is 20. Now, it gets a little bit more complicated when you have a problem with radicals in it. So let's take a look at one more 30, 60, 90 triangle. This one, let's label our spots here. We've got hypotenuse, long leg, short leg. For this one, hypotenuse is over here, long leg is here, and short leg is here. So since we're solving for j, let's go short leg to short leg. J over 1 is equal to long leg over long leg. 7 square root 3 over the square root of 3. Cross multiply a step and you get j times 7 square root 3 equals, oh, I did that wrong, j times square root of 3 equals 1 times 7 square root of 3. 1 times anything is that anything, so j square root of 3 equals 7 square root of 3. Divide both sides by square root 3, and we get j equals 7. One last thing, say you end up with an answer that looks something like this. Before you press enter, take a look. You have to answer in simplest radical form, and that means that you can't have a square root sign in the denominator. So to get rid of that, we're going to multiply by square root of 3. Got to do that to the numerator. Whatever you do to the denominator, we get 2 times square root of 3 over square root of 3 times square root of 3 is just regular 3. This is what you'll want to put into the answer box, not this guy. Good luck.